All right, so today we're going to talk about exponential growth and decay, and we're going to talk about a slightly different equation than what we have been working with. So just to review again, this equation that we have been using, we had the variable a, which we know as the initial amount or the initial value, okay, and then this b was the base, which was essentially my growth or decay factor. Okay, and again, factor, being the key. What are we multiplying by? All right, and so today, the equation we're going to use to solve problems is going to change slightly. We're going to have y is equal to, and then it's going to be usually a capital P times 1 plus or minus, so you're only going to use one of those, r raised to the power of t. Okay, and so it looks very different than the equation that we have been using, but I do want to kind of highlight a few things. Okay, and the first being is that if we look at these equations and we try to find similarities, well, y and y are the exact same, then they're equal to something, and then p is still just like my a value. And so this is still my initial value, but usually with this equation, we're going to be dealing with money. And so we're going to know the variable p to be my initial amount, right? Our initial amount. Or really, it's the same thing, the initial value. Okay, we just using a different variable. The capital P stands for the principal amount. Okay, the principal amount is how much I'm investing in a certain thing. Okay, and so if A and P are essentially the exact same, then we have to be able to look at as well this base of B and everything over here that's inside parentheses. Those two are essentially the same. So the growth or decay factor is now 1 plus or minus the rate. Okay, so this entire thing, and this is what is confusing. So if I say 1 plus or minus r, this is my growth or decay factor. So that'll give me my growth or decay factor, the entire calculation of that. Okay, well, what do I have to know in order to figure out that growth and decay factor? Is I have to figure out what R is. R is known as my growth or decay rate. Okay, so we're going to get a rate. And a lot of times this rate is given to you as a percentage. Okay, and hopefully you'll find that out here in just a minute, but we're just kind of breaking down and deconstructing this equation. So essentially I took B and I replaced it and I split it up with 1 plus or minus a rate now. Okay, but those two things are the same thing. B and the 1 plus or minus R, growth factor versus the growth or decay rate. Okay, and then obviously the last thing that is similar is this exponent of x with that exponent of t. They're essentially the same thing. T here just represents time, okay, in years usually. Okay, so just time. So now we're going to hopefully put this together. So we're going to start working out some problems, okay, and trying to label something. So this is where our notes come in handy. All right, so if we're looking at number 1, okay, here I'm given an equation and then I'm asked a few different things. Okay, so here I have an exponential. I have y equals 1,200 times the quantity of 1 plus 0.3 raised to the power of 3. And it says, what does this function represent? An exponential growth, or an exponential decay. So remember, when I am figuring out if something is an exponential growth or decay, I'm looking at the B value, everything inside that parentheses. And we created those rules last time. If I take 1 plus 0.3, that gives me 1.3. And so that is greater than 1. So we have an exponential growth. Okay. And then part B asks, what is your initial value? Okay, the initial value here is my principal amount, which is the 1,200. Okay, and then I'm going to split this up. So this question right here, C, is asking for the rate of growth or the rate of decay. So I need to figure out what the rate is. The rate is simply this little decimal that is added to the 1. So my rate here, my rate is 0.3. Okay. Sometimes rate is also written as a percentage. So 3 or 0.3 is also 30%. Okay. And then I'm going to add a question right here. We'll just say question D. And what if I said, what is the growth factor? Okay, the growth factor. Well, that comes back to, kind of part A, what I said earlier. I said the growth factor is everything inside the parentheses. What's 1 plus 0.3 is 1.3. So the growth factor is 1.3. So that is the confusing part, being able to distinguish between a growth rate, which is just the 0.3 part, and what is the growth factor, which is 1.3. Okay, so I'm just identifying things from an equation now. And here we go again. Question 2. What does this function represent? Again, I'm looking at everything inside the parentheses. So I have 1 minus 0.02 now, which is now equal to 0.98. 0.98 is between 0 and 1. So based on the rule we created last class period, that tells me that I have a decay. Okay. And then again, what's my initial value? I'm just looking at the principal amount, which is 55. So if you want to, you can say P is equal to 55. And then what is the growth rate or the rate of decay? Sorry, the rate of growth or the rate of decay. So in this case, we have a rate of decay. The rate is simply just the 0.2. So R is equal to 0.02. If I want to write it as a percentage, R is equal to 2%. And we can say decrease here. And I forgot to mention that earlier. So a decrease is just a decay, right? It's a 2% decrease. If I came back up to question 1, we could say that this is a 30% increase because it would be a growth. Question number 3, same concept. Let's look at this. So what does this function represent? So again, we're looking at the entire B value, so everything inside parentheses. Okay, that is 1.25. That is bigger than 1, so we have a growth again. What's my initial value? Again, my initial value is just that 100, so principal is equal to 100. And then the rate, right? The rate, I have 1.25, so I need to understand that I got that by doing 1 plus 0.25. Okay, and so now I'm just using that formula I had from the other screen, right? 1 plus R. So the R is just this decimal, 0.25. As a decimal, or I'm sorry, as a percentage, it's 25%. And we could say it's an increase because it's a growth. Okay, and then the other part, the growth factor is equal to 1.25. It's the entire thing, okay? And then the last example that I'm going to do is example 4. So again, I look at the B value, 0.65. That tells me that this is a decay because it's between 0 and 1. What's my initial value? Is 5,575. And then what is the rate of decay? The rate, this one is the tricky part, right? We know that 0.65, we had to take 1 and subtract the rate. So what can I subtract from 1 that gets me 0.65 is 0.35. So my rate is 0.35 or 35% decrease. Okay. And then again, my decay factor is equal to 0.65. All right, so that's it for the first part. And then now I'm going to go over to the back side. We're going to work a few problems here. This is where we're going to actually find now a future value. So the first one I'm going to do is number 9. And again, the equation I'm using, right, is this equation. And so I have to figure out a few things. It says the first year of a charity walk event had an attendance of 500 people, I'm assuming. The attendance Y increased 5% each year. So I have to understand what we started with. We started with 500. So that is my initial value, okay, or my initial amount. It's P. And then I had a 5% increase. So that is my rate. Okay, so I take what I know and I plug into this equation up here at the top. So I'm going to say that this is going to be Y is equal to 500 times 1. It's an increase, so it's just plus. And then 5% as a decimal is 0.05. We always have to convert it to a decimal. And then raised to the power of t. I can leave my equation like that, or I can simplify it, so that would still be correct. Or I could simplify it to be y equals 500 times 1.05 raised to the power of t. So all I did was perform the addition inside of the parentheses. Okay, and so this equation that I just generated, okay, is the one that I'm going to use to figure out my next question of B. It says, how many people will attend in the 10th year? Round your answer to the nearest person. So this tells me a time. It gives me years. So 10 is time. So I pick one of these two equations. I'm going to pick the blue one. And I simply say y is equal to 500 times 1.05 raised to the power of 10. Okay. And so then now I just simply use a calculator to calculate that number. So if I have 500 people times 1.05% increase raised to the power of 10, I get 814.4445. Okay, so it did ask us to round to the nearest person. So we're just going to say it's instead of having an equal sign there, we're going to have an estimated. It's estimated to have 814 people. Okay. And then let's go ahead and do number 10. Number 10, the population of a small town was 3,600 in 2005. The population increased by 4% annually. So again, I have my principal, I have my rate, we write the equation, y equals 3,600 times 1, an increase is plus, 4% as a decimal is 0.04, all raised to the power of t. If you want to, you can simplify. Y equals 3,600 times 1.04. Those two equations are the same thing. Okay, these two are the exact same thing. And then we just use whichever one. We'll use the top one this time. Y equals 3,600 times 1 plus 0.04 raised to the power of, and I haven't figured that out yet. It says, what will the population be in the year 2025? Okay, well, our initial year was 2005. Now I want to know the population in 2025. So essentially, I'm subtracting and finding the difference of those two, which is just 20 years. So there's a gap of 20 years. So that tells me my time. So I raise this to the power of 20. Okay, so what is that going to estimate to? Again, because this is people, we're going to estimate to the nearest person. So here I go 3,600. I said I was going to do the one with plus, raised to the power of 20. So we get 7,888 people. So we're going to just go to the nearest whole number. So we're estimated to have 7,888 people. Okay, and those are two quick increase examples. Okay, and everything's, based off of that equation I've been giving you. So let's skip down to number 13. Okay, in number 13, we have a yearly profit that a company makes. So this is the principal. The profits have been decreasing, okay, by 6%. That's my rate. Okay, so decreasing, we have to understand we're going to subtract now. So again, I write my equation. Y equals 25,000 times 1 minus 0.06 raised to the power of t. Again, I'll simplify. Y equals 25,000. And then it's going to be times 0.94 raised to the power of t. And then I'm going to use that second equation so that I can estimate what the profits will be in 8 years, which gives me my time. So we have y equals 25,000 times 0.94 raised to the power of 8. And so it is estimated that we have $15,239.22 left in our profit. Okay, so it's been decreasing for by 6% for 8 years. And then the last example I'm going to do is 15. So it says we bought a car, we have a car. So this is the principal. When you purchase it in 2015, so this is the initial year, the value of the car decreases by a rate of 15%. It says write an equation to represent this. Y equals 42,500 times 1 minus 0.15 raised to the power of t. And then we have y equals 42,500 times 0.85 raised to the power of t. Again, I just did the subtraction inside the parentheses. And so that's the equation that I like using. I have one too many zeros there. Times 0.85. And again, I need to figure out what I'm going to raise the 0.85 to. So how much will the car be worth in the year 2022? So again, 2022 minus 2015 gives me 7 years. So I'm going to raise it to the power of 7. This is money, so we're going to round 2 decimal places. Whenever I calculated that earlier, I got a grand total of $13,624.53. So my car has depreciated in value by quite a bit.